In today's video, we're going to be talking about projectile motion and some strategies for doing problem solving with projectile motion. After watching this video, you should be able to use some of the strategies that are being presented to solve some problems dealing with projectile motion. Know the 5 kinematic variables that can be manipulated in a projectile motion problem, and then be familiar with the kinematic equations that are presented here. I'm not expecting you to memorize them. This is something that I would think you would put on a note card if you were to take a test or a quiz, but you should be familiar with them so that they're not completely like, I've never seen this before type of deal. So let's get right into it. Basically, there's going to be 2 types of problems dealing with projectile motions, and I'll talk about both types actually in this video. The first type of problem is a projectile that's launched with a initial horizontal velocity from an elevated position. So it could be something like a ball rolling off a table, a boulder being pushed off a cliff, you know, you name it, as long as it's just being pushed off of something or launched off of something with a horizontal velocity and no actually initial vertical velocity, that's one type of problem. The second type of problem is a projectile that's launched at an angle to the horizontal and rises upward to a peak while still moving horizontally. And so that sounds probably more confusing than I'm really making it out to be. Let's say I shoot a cannon at an angle, or I throw a football at an angle, or a baseball, or whatever the case may be. So I'm launching something to another point. That's the second type of problem that we'll see. And like I said, I'll talk about both of these in this video. So let's keep on moving. There are 5 kinematic variables, and I believe we've kind of touched on these before, but I want to make sure everyone's clear on them again. Okay, so there's 5 variables that you should be familiar with. There's something called delta D, or sometimes you'll just see it as D, and that stands for displacement. Okay, and typically the displacement is measured in meters, and it is a vector. Okay, so that means that it has a number value or a magnitude and a direction. Okay, the second one I'd like to talk about is V sub I. Okay, and V sub I stands for the initial velocity, and that too is a vector, and it's measured in meters per second. Okay, so it has a number value and a direction. Now, in this V sub I, we know that there is typically how we're going to do these problems is we have an X component or a Y component. Okay, so there's a velocity in the X direction, and then there's a velocity in the Y direction. Okay, the other type is called V sub F, which is the final velocity, the velocity at which the object ends with. Final velocity. Also measured in meters per second. It too is a vector, and you again will see this in the X or really Y direction. Okay, so a lot of times there's a final X velocity and there's a final Y velocity. 2 things to keep in mind with V sub I and V sub F. Sometimes students are a little bit scared to say it's 0. 0 is a real possibility. So I mean, you could have an initial velocity of 0, and that's perfectly fine. So don't be afraid to sometimes put 0 in as that variable, because sometimes it is. You have to read the problem and try to use your noggin to figure out if it actually is 0 or not. Okay. The next one is acceleration. Okay. Acceleration, or I'm sorry, A is for acceleration. Acceleration. Whoops, can't spell today. Acceleration, which is meters per second squared. Okay, remember, an acceleration is a change in velocity. It too is a vector, and you can have an acceleration in the X or Y direction. Now notice I don't have A initial or A final. Basically, when you start getting into like accelerations that are changing throughout the motion of an object, that starts to involve some calculus, and that goes beyond the scope of this course. So our acceleration will always either be like 0 or it'll be just a constant acceleration. Okay, the acceleration won't change throughout the motion. okay? And then the last one is t, which stands for time, and it's measured in seconds, and it is called a scalar, okay? Time doesn't really have a direction per se, okay? And this is actually shared in the x or y direction. Okay, so here they are, the 5 kinematics variables. If you want numbers next to them, here you go. These are 5 that you'll want to know, and you'll probably want to write down for every problem. Okay, like 5 kinematics variables. Now, these equations, there's 5 of them, okay, which turns out to be quite convenient, and I'll tell you why in just a second. There's 5 of them, and these equations you use when the acceleration does not equal 0. Okay, when the acceleration does not equal 0. So if for instance, let's say I have an acceleration of 4 meters per second squared, positive 4 meters per second squared, I would then be looking at some of these equations. Okay, if my acceleration equaled 0, I would use a different set of equations which actually are considerably easier than these. Okay. One of the big things, and we'll talk about this more in class, is that you'll notice each of these equations are missing one of the 5 kinematic variables. All right, and I'm going to go through that because it turns out to kind of be useful in terms of what they're missing. Okay, so this first one, I'm just make a little chart here. Make a little chart. What are they missing? I'm going to put it in here. You'll notice that this first one is missing delta D. Okay, there's no displacement in this equation. So if the problem gives you an initial velocity, a final velocity, and an acceleration, you could then solve for time. Or if it gives you time, v sub I, v sub f, you could then find acceleration. Hopefully it's kind of making sense. So if the problem doesn't give you displacement, but is looking for one of those other 4 variables, and you have the other 3, you can solve for it. Okay, so this one is missing displacement. What is this guy missing? Well, this guy is missing the acceleration, right? The A. What is this one missing? This is missing time. Okay, so basically it's not in the equation at all. So you don't even need to worry about these variables, if you will. Okay, what is this guy missing? This one is missing the final. Okay, there's no final velocity in the equation. And this guy is missing the initial. There's no initial velocity in the equation. Okay, and you notice these 2 equations are like exactly the same, except that this v sub I and v sub f are just, you know, flipped. Okay, so basically you can use either one. It's just these are what's missing. Okay, so just kind of keep those in mind. And these are the 5 equations. Not expecting you to memorize them, but it's something that you definitely should have in a handy place, and you can refer to it relatively easily. So when the acceleration equals 0, you want to use this. And sorry, I should have probably called this d instead of x. So the displacement equals velocity times time. Okay, this is just the good old-fashioned like middle school equation of basically speed, right? I mean, speed equals distance divided by time. I just have it kind of switched around here. Displacement equals velocity times time. This equation works for when the acceleration equals 0. All right. Now, I don't know if you are a person who likes kind of a step-by-step approach for solving problems, but this is a real nice step-by-step approach, and if you're struggling with these problems, I recommend following this method. And this method will kind of help you not make silly mistakes. It doesn't guarantee, you know, the right answer every time, but it does help you not make silly mistakes and that type of thing. So I'm just going to go through this real quickly, and this is something you could certainly refer to if you're stuck on a problem, saying like, did I cover my basis with each of these steps? So the first thing is keep dude in mind as you solve problems. Remember, that's a mnemonic device. It's up on the front of the classroom, where D stands for draw the problem, U stands for uncover knowns and unknowns. That means like write them down. D stands for decide on a formula, and E stands for execute algebra. This is something that I highly recommend keeping in mind as you solve any physics problems in class. Drawing the problem, I think, is super useful. Writing down your knowns and unknowns, super useful. And then figuring out the correct formula and then doing the math correctly. So make sure you do the dude. Got it, dude? All right, good. So step 1, draw the object's path, label the initial and final position. Okay, so drawing that picture and annotating the picture is important. Step 2, decide on which axis is positive. Okay, typically, when I do problems, this way is positive and this way is positive. So up and to the right are positive. So down and to the left are negative. Signs are huge in these problems, so do not forget your signs. And I'm actually going to stress that you actually put positive in front of positive numbers and negative in front of negative numbers. I think that's a really good way to help yourself not forget the signs. If you put a sign in front of every number, you kind of just get into the habit of doing that. Okay? Step 3, break displacement, velocity, and acceleration into x and y components. Okay, remember those are all vectors, and so they can be broken into components. And we had talked about that in a previous lesson. If you forgot how to do that, check out one of the previous lessons about vectors, and you can figure out how to break vectors into components. Step 4, is the acceleration 0 in the x direction? What about the y direction? If it's 0, that's really helpful. Why is it really helpful? Well, you can use that equation d equals v times t if the acceleration is 0. You only have one equation that you're worried about. Okay, so it's really useful. In the notes, or in the previous slide, I had that as x, but I said, oh, I wish I would have put it as d, so I apologize. But it's just one equation if the acceleration is 0. Okay. Step 5, write down the 5 kinematic variables if a, sorry, and this looks like kind of weird, but if a is not 0, so if the acceleration is not 0, and then identify the variable that you're looking for with a question mark. Okay, what is it that you're trying to find out in the problem? That really kind of helps keep things clear. So you have all the variables written down. What is it you're trying to figure out with a question mark? Then step 6, pick an equation and begin to solve. Okay, I'm going to try my best to follow these steps as best I can in the following example problems. All right, so you can kind of get this or see this in action as we go through it. Some other things to keep in mind that it's like a lot of times teachers just don't tell students, okay, which is kind of a shame because I think these are important things. Time is the same for the x and y component. Okay, so time is a huge key to unlocking a lot of these kinematic equations. So you try to figure out the time first, unless they give it to you, which is wonderful if they give you the time of flight or the time it took for the ball to hit the ground. But a lot of times they ask that question, well, how long did it take the ball to hit the ground? So if you can figure out time first, that's huge. For projectile motion, the initial velocity in the x direction, and only the x direction, is the same as the final velocity in the x direction. And the reason why is because there is no acceleration in the x direction with projectile motion. If you remember, what is a projectile? A projectile is something that is experiencing only a force due to gravity. Okay, so the acceleration is only down. There is no horizontal acceleration unless it has like an engine on it or a jet or whatever. But we're not dealing with that right now. We're talking about projectile motion, which is basically the only force acting upon it is the force of gravity. So your initial velocity in the x direction does equal your final velocity in the x direction. So they might only tell you the initial velocity, but they're assuming you know in your head that the final velocity is the same. Okay, and so once again, these are the types of things they don't just tell you. For projectiles launched at an angle, the initial velocity in the y direction will be the same as the final velocity in the y direction, except just with an opposite sign at the same point. Okay, and this sounds kind of confusing. But let's say I throw a ball, and let's say the initial velocity here in the y direction is, I'll say, I don't know, 10 meters per second. Okay, and this ball follows this kind of path. Okay. If I drew this perfectly, this opposite point over here, what is the final velocity in the y direction? Well, it's just negative 10 meters per second. Okay, and that's due to the symmetrical nature of projectile motion. Right, that there's some symmetry here, and so because of that, the initial velocity here in the y direction is 10 meters per second, and then the final velocity at the opposite side at the same height is negative 10 meters per second. So these are just some things to kind of keep in mind. It's a non-horizontal projectile. And basically a non-horizontal projectile is a projectile that begins its motion with an initial velocity that is both horizontal and vertical. Okay? So my example is a football is kicked with an initial velocity of 25 meters per second and an angle of 45 degrees with the horizontal. Determine the time of flight, the horizontal displacement, and the peak height of the football. This example problem, along with a just horizontally launched projectile problem, can be seen in the video that says projectile motion example problems. This video just got a little bit too long, and so I have since cut it into two different pieces. So if you want to see some examples on how to do these problems, which I highly recommend doing, check out the other video. But if you feel like, oh, I can do something like this and get the correct answer, then I guess don't worry about it. That takes care of this video. I will see you guys next time.